For this lesson, we're going to be looking at classifying different geometric figures using some of the principles that we've developed so far in this unit, and actually from units before, some concepts from before this unit, and actually some concept brought forward from previous courses. So you might want to pause here and just take a look at the screen and consider some of the questions that I've got on here. If I gave you 3 points, well, 3 points can be, you can draw line segments between those points and you formed a triangle. There are different types of triangles. Equilateral triangles have all 3 sides equal. Isosceles triangles have 2 sides equal and then the third side is different. Scalene triangles, all 3 sides are different. So what principle or principles have you learned so far that might allow you to classify a triangle between those 3? How would you be able to determine whether or not you have a right triangle? What is the definition of a right triangle? It means that one of the vertices or one of the angles at a vertex is a 90-degree angle, which means that 2 sides meet at a 90-degree angle. What principle could you use to determine that? What if we went to 4 points? So now we formed a quadrilateral. What are the properties? Can you remember the properties of a parallelogram? And then how would you determine whether or not you have a parallelogram? What about the properties of a rectangle? A rectangle is a very specific type of parallelogram. So what changes from being a generic parallelogram into a more specific rectangle? What are the properties of a rhombus? So a rhombus is a very particular type of parallelogram. So parallelogram leads to rectangle, parallelogram leads to rhombus. And then a rhombus is a very particular type, a square is a very particular type of rhombus, or it's a very particular type of rectangle, depending on how you view these things. So how are we going to make use of properties that we've talked about? And the types of properties that we're going to be making use of in this lesson, we're going to be making use of the idea of distance, in particular the distance between points. We're going to be making use of the idea of parallel and perpendicular slopes. When we talk about parallel and perpendicular, we do those in the context of the slopes of various straight lines. And really, those 2 concepts are going to be the key concepts here, the distance between points and the idea of parallel and perpendicular slopes. Because perpendicular will get us into this idea of right angles. Parallel, well, that's, do I have a parallelogram? Parallel lines with some perpendicular lines, that's how we get into rectangles. Squares and rectangles dealing with the distances of the different sides. So let's try to put some of these ideas, very simple ideas. The distance formula we've covered, parallel and perpendicular slopes, calculating slopes, you've done a lot of that. And you can see here I say we're going to make use of slopes of parallel and perpendicular lines, distance formula. We are going to make use of the midpoint formula, which is something we covered in the lessons on analytic geometry, but that won't be our focus to start, I don't think. When you have a problem on classifying a geometric figure, it's never a bad idea to draw a diagram. The neater the diagram, the better. So if you have a coordinate grid available, then you should use that. But I'm going to show you in our first example, that's not even super important, so long as you can do a reasonable sketch. So a triangle has vertices at -2, 2, -1, -3, and 4, 1. And we want to show that it is not a right triangle. And so the definition of a right triangle would mean that there is a right angle somewhere. So let's start by drawing this, and I'm going to do a very rough sketch of this. So I'm just going to say, well, -1, -2 for the x, and then +1, +2 for the y. So there's my rough idea for the point P. -2, 2. Q is at -1, -3, -1, -2, -3. So there's the point Q, -1, -3. And the point R is at 4, 1. 1, 2, 3, 4,+1. There's the point R, 4, 1. I am going to use, since I've got technology here, I'm going to join my points at least using straight lines. This is my version of using at least a ruler to get something. Now, when you draw a diagram, even if you've been very careful and you've done this on graph paper, this is just a guide. Your diagram cannot actually be your mathematical justification for the answer. So showing that this is not a right triangle, I've drawn a pretty good diagram here. Oh, I don't see any right angles. Obviously, this is not a right triangle. Well, that can't be the case. You can't look at it that way. So what we need to do is we have to establish that something's not a right triangle. So let's remind ourselves that for a right angle, what does that mean? If we have a right angle, that means we have perpendicular lines. And perpendicular lines, when we talk about perpendicular lines, we're really interested in the slopes of those lines. So what I can do is let's determine the slope of the line segment PR, the line segment PQ, and the line segment QR. So I'm going to do this alphabetically. So what is the slope of PQ? And just to remind you, I'll just put this up here. I'm sure most of you would be familiar with this, but the general equation, y2 minus y1 over x2 minus x1, that's the general equation for a slope. So PQ, that means that in this case I'm using P as the first point, Q as the second point. So when I do y2, that's going to be the y value from Q, which is -3, minus y1, which is the y value from P, which is +2. I'm putting brackets in here just to be super careful. I don't want to get caught up on missing out any negatives that turn into positives from subtraction. Now I do the x-coordinates. The x-coordinate of Q is -1, minus the x-coordinate of P is -2. This is a case where the brackets help me out. So -3 minus 2, that's actually quite straightforward. That's -5. -1 minus -2, I'm going to take the extra time to write this out as -1, and a negative of a negative becomes a positive. And we end up with -5 over -1 plus 2 is equal to 1. And you might simplify that to be simply equal to -5. So that's our first slope. Now let's find the slope of, that was PQ, let's do PR. y2 minus y1, in this case R is going to be my 2, P is going to be my 1. You could do it the other way around, that's up to you, it will work out. So the y coordinate of R is 1 minus the y coordinate of P, which is 2. The x coordinate of R, which is 4, minus the x coordinate of P, which is -2, is equal to, notice I've got a negative of a negative here. I'm going to do this a little more quickly this time. 1 minus 2 is, I'm going to go straight to -1. And 4 minus -2 is the same as 4 plus 2 is equal to 6. And then finally, the slope of QR is equal to, R is my second value. So the y value of the second point minus the y value of the first point. The y value of R minus the y value of Q over the x value of R, which is 4, minus the x value of Q, which is -1. Brackets really pay off here. 1 minus -3 is 1 plus 3 is equal to 4. 4 minus -1 is 4 plus 1, which is equal to 5. Now, if you remember, when we've talked in the past about a perpendicular slope, so for a perpendicular slope, let me just So for my perpendicular slope, to determine that, I would take the negative reciprocal. Okay, so what I could do is I could look at this one, for example, as -5. So if I wanted the perpendicular value to that, I would take the negative of that, turn it into a +5, and then take the reciprocal, so 1/5. But there's actually, when I'm comparing slopes, so this is if I'm trying to find a perpendicular slope. But if I want to compare slopes, there's actually a more formal way to do this. And the way you show that two slopes are perpendicular to each other is if m1 multiplied by m2 equals -1. So if a slope multiplied by, and the reason why this works, if this multiplies out to give -1, that means that one of them is the negative reciprocal of the other one. So if this is equal to -1, that means that the lines are perpendicular. So let's see whether or not that's actually the case here. We have PQ. So the slope of PQ is equal to -5. So I'm going to say slope of PQ times the slope of PR is equal to -5 multiplied by -1/6, which is equal to a negative times a negative becomes a positive. Don't forget that this -5 is the same as -5/1. So -5 times -1 is simply equal to +5. 1 times 6 is equal to 6. Is that equal to -1? No, it's not. So that means that these are not perpendicular. So now let's take a look at another one. MPQ times let's look at MQR. We already did PR, so let's do QR. So MPQ, once again, is -5. MQR is 4/5. If you notice that 5s, again, just to remind you that this is over 1, but 5 divides into 5 once, 5 divides into 5 once. So we end up with -1 times +4 is -4 over 1 times 1 is simply equal to 1. And we would normally simplify that to be -4, but that's really not important here. The important thing here is when I multiplied these two slopes together, I didn't get -1. So these are not perpendicular. Oh, I didn't mean to go to the next page. So this is not perpendicular. This is not perpendicular. And so the last pair I have to do is MPR with MQR. MPR and MQR. So what was MPR? I can see it here. It was -1/6. What is MQR? It's 4/5. And when I multiply that out, again, just noticing 4, let's see, 2 goes into 4 twice, 2 goes into 6 3 times. And that's the only simplification I can make. -1 times 2 is -2. 3 times 5 is 15. And so this one is also not perpendicular. Therefore, it, or let's not say it, let's say therefore triangle PQR is not a right triangle because it doesn't satisfy any of our conditions for perpendicular lines. Next example, we're actually going to use the same points. This time I've actually used technology. I've graphed them very nicely. taking a look at this, is this triangle scalene? Does it look like all of these sides are different? Well, we can't trust it. I would say just looking at it, it could be scalene, but there's a chance that it's isosceles. This side does look shorter than these other two sides, but PR and QR, they look like they might be the same length. I can't be sure. So the way that I do that to find scalene is I'm going to compare distances. So I'll remind you the distance formula. Distance is equal to x2 minus x1 all squared plus y2 minus y1 all squared, and then take the square root of that whole thing. So using good labeling, let's find what the distance between, let's do it in the same order we did the previous example, PQ. So what is the distance between PQ? I'm going to write this out once fully, and then I'm going to start to take out this additional step. That would be the x-coordinate of the second point, which would be Q, minus the x-coordinate of P, all squared, plus the y-coordinate of Q minus the y-coordinate of P, all squared, square rooted. So that's equal to the x-coordinate of Q is equal to -1. You can get that from the diagram or the original value. So that's -1 minus the x-coordinate of P. Using brackets, that's -2. I have to take that whole thing squared, plus the y-coordinate of Q, which is -3, minus the y-coordinate of P, which is 2. I don't actually need to put the brackets around this one, but I'm going to, just for consistency. And don't forget you're taking the square root of that whole thing. -1 minus -2 is the same as -1 plus 2. -1 plus 2 is just 1 squared. Plus -3 minus 2 is -5 squared, square root. 1 squared is simply equal to 1. -5 squared is equal to +25 square rooted, and that is equal to the square root of 26. And I'm not going to round this, I'm just going to leave this as is. This is an exact value, and this is good for comparing things. Let's move down, give ourselves, actually I'll move over to this side. I think I've got room here. Maybe I'll switch colors just to make sure it's very clear. We're doing a second one. The distance between PQ is done. We're going to do the distance between PR. And you could do the distance between RP, it would be the same thing. It's the x-coordinate of the second one, that's R. The x-coordinate of the second one is 4, minus the x-coordinate of the first one, which is -2, that's P, and that whole thing squared, plus the y-coordinate of the second one, that's the y-coordinate of R, is 1, minus the y-coordinate of P, which is 2, and that whole thing squared. It's going to be so easy to mess up between the x's and y's here. If you need to take the time to write it out with this many steps and get it right, if that's what you need to do to get it right, then take that time. Believe me, it is worth it. 4 minus -2 is the same as 4 plus 2, which is equal to 6 squared, plus 1 minus 2 is -1 squared, square rooted. That's equal to 36 plus +1 is just 36 plus 1, and that's equal to the square root of 37. So that is obviously not the same as the square root of 26. Let's do our last one. The distance between, we did PQ, PR, now we have to do QR. So the y-coordinate of R, which is 1, minus the y-coordinate, oh sorry, I've been doing it x's first. So the x-coordinate of R, so it's x2, so the x-coordinate of R is 4, minus the x-coordinate of Q is -1, all squared, plus the y-coordinate of r, which is 1, minus the y-coordinate of q, which is -3, all squared, square root that whole thing. 4 minus -1 is equal to 5 squared, plus 1 minus -3 is 1 plus 3, which is equal to 4 squared, square rooted. We end up with 25 plus 16, square root of that, and that becomes 41. Square root of 41. And so, since none of the sides are equal to each other, so this symbol, since no sides are equal, therefore, again, I'm not going to say it, I'm going to say triangle PQR is scalene. And I didn't spell scalene properly. Scalene. Okay, so that was using the distance formula. And I believe this is the final example. Determine the type of quadrilateral, so this is a four-sided image, or a four-sided shape. We've got the point P at -2, -2. So I'm going to do a very rough sketch this time. We've got Q at x equals 0, y equals 4. So there's Q. We have R at 6, 3, so that's way out here. And we have S at 8, -1. I've actually messed up my scale because this is, so this, I need to bring these things in a little bit closer. So instead I'm going to put P closer to here. And then Q is at 0, 4, so that's about there. R is at 6, 3, which is around there. And S is at 8, -1, so that's around there. R and S, and I've admitted up front I was being very rough with this. If you had some graph paper, you could certainly do a better job of this, but this is just a visualization thing. And we are trying to determine what type of quadrilateral we have here. So based on what I'm seeing here, well, there's nothing that jumps to mind. I don't look at this and nothing leaps out at me. So what type of quadrilaterals can we classify? And that takes us all the way back to our original slide. Parallelogram, rectangle, rhombus, or square. Well, looking at this diagram, I don't actually see any of them. But in order to classify this, what I can do is figure out slopes of the lines involved. I can figure out the distances between the various points and see whether or not it meets any of my definitions for parallelogram, rectangle, rhombus, or square. Okay, so we've got some work to do here. Let's start with the slopes. So the slope of PQ, I'm going to try to do this just alphabetically. The slope of PQ, so I take the y-coordinates of P and Q, so that'll be the y-coordinate of Q minus the y-coordinate of P over the x-coordinate of Q minus the x-coordinate of P, and I end up with 6 over +2 is equal to 3. The slope of QR is equal to the y-coordinate of R, which is 3, minus the y-coordinate of Q, which is 4. When the value is positive, you don't need to put brackets around it because having the brackets there doesn't actually help you. The brackets are in case you're doing a subtraction of a negative. The x-coordinate, the x-coordinate of r is 6, minus the x-coordinate of q is 0. So 3 minus 4 is -1. 6 minus 0 is just equal to 6. The slope of, let's see, PQ, QR, RS is equal to the y-coordinate from S, which is -1, minus the y-coordinate of R, which is 3, over the x-coordinate of S, which is 8, minus the x-coordinate of R, which is 6. -1 minus 3 is -4. 8 minus 6 is equal to 2, and that simplifies just to -2. And we come all the way back around, so now we're going to do the slope of PS, which is our last line. The y-coordinate of S is -1. The y-coordinate of P minus -2. We need the brackets here. The x-coordinate of S, which is 8, minus the x-coordinate of P, which is -2. Need the brackets again. -1 minus -2 is the same as -1 plus 2 is equal to +1. 8 plus 2 is equal to 10. So there we go. We have our slopes. So taking a look at this, can we say, are any of these things parallel, perpendicular? There's certainly, we have no parallel lines here because none of the slopes are the same. And none of them are perpendicular. If you needed to do that test, multiplying the slopes, you could. But I can do this by inspection. The negative reciprocal of this would be -1/3, nowhere. The negative reciprocal of this would be 6, nowhere. The negative reciprocal of this would be +1/2, it's not there. And the negative reciprocal of this would be -10. So none of these appear anywhere within the... None of the negative reciprocals are anywhere else. So I know we are not perpendicular. Now, what about distances? In order to do the distances, I actually think I'm going to copy this page. Let's see, a quick way to do this. And I'm just going to clone the page. I don't think it cloned the page I wanted it to. There we go. And then I'm just going to get rid of all this stuff. And now I'm going to do the same set of calculations, except for this time I'm going to go ahead with the distance calculations instead. So the distance between PQ, let's start with, do again alphabetical order. The distance between PQ, I subtract the x-coordinates, x2 minus x1. x2 minus x1 is 0 minus -2, and then I have to square that whole thing, plus subtract the y-coordinates. It's going to be, we're doing PQ, so it's going to be 4 minus -2, and square that, is equal to 0 minus -2 is +2, and +2 squared is equal to 4. I'm going to skip one step there. 4 minus -2 is 4 plus 2 is 6, and 6 squared is 36. And so I end up with the square root of 40. The distance of QR is equal to, so for QR, I'm going to do the difference in the x-coordinates. 6 minus 0. So 6 minus 0 is simply equal to 6 squared. The difference in the y-coordinates for QR is going to be 3 minus 4. That's equal to -1. What is -1? Actually, I'll put it in, -1 squared. So you can see, if you get more comfortable with these things, there are some shortcuts that you can take. And so this one works out to be 36 plus +1 is 37. The distance of, let's see, QR, so now we're going to do RS. That's equal to, what's the difference between RS? What's the difference between the x-coordinates? Between 8 and 6 is a distance of 2, and 2 squared is 4. Between -1 and +3, that's a distance of 4, and 4 squared is equal to 16. So that is equal to the square root of 20. And finally, the distance between P and S is equal to, now you can see I reduced my number of steps increasingly between these. So now let's just go back and remind, how do we do this with a full set of steps? We're going to take the x-coordinate of S, which is 8, minus the x-coordinate of P, which is -2. So 8 minus -2, and I have to square that whole thing. Then the y-coordinate of S, which is -1, minus the y-coordinate of P, which is -2, and square that whole thing, and then take the square root. So 8 minus -2 is equal to 10 squared, plus -1 minus -2 is -1 plus 2, so that's equal to +1 squared. And 10 squared is equal to 100, and 1 squared is equal to 1, so this is the square root of 101. Now this is where having your diagram actually can come in quite handy, because now when I take a look at my different distances, if I've done a decent diagram, at least I get an idea. PS does seem to be like the longest side, RS does seem to be like the shortest side, and PR and QP seem to be about the same, and they're pretty close to each other. So having done that, what is my conclusion here? Can I classify, determine the type of quadrilateral described by these points? It turns out that we cannot classify. There are no perpendicular sides, and there are no right angles. Oh, I already said that. Sorry, that's no perpendicular sides. And there are no equal sides. So therefore, this should actually not be a therefore, this should be a since. Since there are no perpendicular sides, and since there are no equal sides, therefore we cannot classify our quadrilateral. Okay, so that got a little long in the end just because of the number of calculations we had to do. But those are the tools that you can use. Basically, it's looking at slopes and distances and comparing them to classify different shapes, whether triangles or quadrilaterals.